All right, let's talk about parallel lines. Say, what are parallel lines? What are they? Well, two lines are parallel if they point in the same direction. What I mean is, they're lying parallel to each other. You know what parallel means in English. So if I draw two lines that point in the same direction, we call those parallel. What else do we know about these lines? Look at them. The distance between them is always going to be the same. It's always going to be this number, so they're never going to meet. Here's one more thing we can say about parallel lines, is that they have the same slope. The slope is another way to describe the direction, so if they're parallel, they have to have the same slope. The really cool thing is that any one of these 3 points is enough to prove that lines are parallel. So if you know one of these is true, then you know all 3 of them have to be true. And if any of them is false, then you know all 3 have to be false. So if I give you two lines and I say they meet, well, then you know they can't have the same slope. Whereas if I say they don't have the same slope, well, then they have to meet somewhere. Either all 3 of these are true or they're all false. So these 3, all true or all false. We call these equivalent conditions. And in mathematics, it's really fun when you can get equivalent conditions, because we essentially get 3 pieces of information for the price of 1. It's a form of symmetry. So for example, maybe this is the line y equals x, x minus 1, and this is y equals x plus 2. Those are parallel because they both have a slope of 1. Here's the other relationship I want to talk about. Perpendicular lines. They meet at a right angle. Their slopes are a little trickier. We'll talk about those in a second. First, let's look at what happens if they meet at a right angle. Here's an example. This is y equals 1/3 x minus 1. Let's say that this line is perpendicular to it. I see the y-intercept is about 4, so I'm going to put in a plus 4 there. But what can I say about the slope? First off, the one slope was positive, so if this is going to be perpendicular to something with a positive slope, scroll, okay. This is going to be perpendicular to that thing with the positive slope. This has to have a negative slope. If they're both positive or both negative, there's no way they're perpendicular. So if this one was positive, this one's negative. Also, if this one was shallow, then this one has to be steep and vice versa. If they're perpendicular lines, if this is really a square angle right here, and here, and here, and here, 4 square angles, because that's what makes a full circle. One has to be shallow and one has to be steep. So you're always going from positive to negative or vice versa, which means we're multiplying by a -1, and you're always going from shallow to steep or vice versa. Well, fractions like 1/3 or 1/5 would give us a shallow line. Whole numbers like 3 or 5 would give us a steep line. So what we're going to do is take this number, flip it, and reverse it. And if it's big, let me search it. We're going to get -3x plus 4. Check that out. So the way we get from one slope to the other is they have, here's the adjective form, opposite and reciprocal, that means flipped, slopes. So make it negative and flip it. Here's 2 lines that are perpendicular. Here's another 2 lines that are perpendicular. Y equals 2x plus 1. And, oops, that's not shallow enough. This is shallow enough. Y equals -1/2 x plus 5. Oh, I said 5, I wrote 4. So here's perpendicular lines. So if I want to know the perpendicular slope, you flip it and reverse it. All right. So Now that we know what they are, we're going to find some. Let's say a line passes through the point -2, 6 and is parallel to this line, y equals 6x minus 29. Oh, 29. What is its equation? Well, let's see here. I know that the slope has to be 6. That's because they're parallel. And you're parallel if and only if you have the same slope. I made this arrow point both ways because parallel gives us same slope, and same slope would give us parallel. So I use this arrow that points both ways to represent that mathematically. You'll see it a few times this semester. Alrighty. Parallel lines have the same slope. So this slope is 6. Here's two different ways we can go about this from here. I want to show you both. I could use point slope form. So I could say my point, x1, y1, is -2, 6. Point slope form says y minus y1 equals m times x minus x1. So y minus 6 equals 6x minus -2. Distribute that 6. Y minus 6 equals x plus 6x plus 12. Whoops. Add the 6 to both sides. Y equals 6x plus 18. That'll do it. Or here's a different solution. Instead of point slope, I could use slope-intercept form. I could say, well, I'm going to take y equals mx plus b. I know the slope is 6. I can fill that in right away. Now I've got a specific point, xy equals -2, 6. I know that that point is on the line. So I know that this equation is true when I fill this specific guy in. So specifically, 6 equals 6 times -2 plus b. Do you see what this gets me? Now the only unknown in this equation is the b, the parameter for the intercept. So I can use this to solve for it. I can say 6 equals -12 plus b, add 12 to both sides. 18 is equal to b. Well, now that I know b, I can go back to here and fill in that last piece of information. Y equals 6x plus b is 18. Same answer both ways. Math is consistent. What did I tell you? But you can use either one of these solutions, slope-intercept or point slope. Whichever one you prefer is fine by me. It's just a matter of, can you get the answer? Alrighty. Let's do one more example, and then we will sign off for Unit 1. After this example, you are all prepared for the test. There's a study guide online. I figure every week and a half or so, we'll have a big ol' study session for each test. We'll try to space those out, one every 2 weeks or so. We got 7 weeks of class, so a little less than 2 weeks, yeah? Okay. This line is perpendicular to y equals -2x minus 33. And it passes through, how about 10 comma -3? We're going to try to find its equation. All right. So this slope of -2, I'm going to flip it and reverse it. So now it's a positive 1/2, and that's my new slope. So now you can use either equation. Let me try point slope. I can write y minus -3 equals 1/2 of x minus 10. Distribute the 1/2, y plus 3, because that's minus -3, equals 1/2 x minus 5. And subtract the 3 from both sides. Y equals half of an x minus 8. try it the other way. I know that y equals mx plus b is going to get me y equals 1/2 x plus b. Now, specifically, that means that -3 has to be 1/2 of 10 plus whatever b is. This equation is true for all the points on the line, but that means it's true for this point specifically. Now, b is my only unknown. -3 equals 5 plus b. Add 5 to both sides. No, subtract 5 from both sides. -8 equals b. Fill that back in. Y equals 1/2 of an x minus 8. Same answer. Before we go, let me make sure that this is correct with my intuition here. So y equals -2x minus 33. Ooh, that's way the heck down there. This is y equals -2x minus 33. Let's draw 1/2 x minus 8. That'll look something like this. Okay, they really are perpendicular, and this really goes through 10, -3. Okay, we are in good shape. So we're all done. That is Unit 1. See you later, alligator.